Let us discuss this problem of electrostatics. It may be useful for JEE mains as well as JEE Advanced. इसमें दिया है कि there is a circular non-conducting ring से आप certain radius r. इसकी radius r हम known मान लेते हैं. And this ring is carrying non-uniform charge density such that linear charge density at angular position as shown here, theta, is varying according to this function, where lambda naught is a constant. You can treat the xy plane, the plane of ring, center at origin. So at this angular position, linear charge density is lambda naught sine theta. Lambda naught is known. What we have to find? First thing, total charge on half of the ring from theta equal to 0 to theta equal to pi radian. Means the portion, I think in this portion, this will be only positive charge because sine theta is positive between 0 and pi angle. So we have to find charge on this portion. Second part, dipole moment. So because you can prove that charge on this portion will be same as magnitude of charge on this portion, but this will be negative. So total charge is 0. So this system will act as a dipole, and we have to find dipole moment of this system. And next question is net electric field at the center. You try and then see the solution. It is not very tough question. It is using more of integration. Now let us discuss the solution. To find the charge, consider a small element because charge is distributed on circle. So on circle, a small element means element making angle d theta at the center. To consider an element making angle d theta at the center at angular position theta. And this element will be of length r d theta. Multiply this r d theta with linear charge density here. Linear charge density मतलब उस पर यूनिट लेंथ पर चार्ज. अगर यूनिट लेंथ पर चार्ज यहाँ लैम्डा है और इस थीटा एंगुलर पोजीशन पर थोड़ी सी लेंथ जो है वो आर डी थीटा लिखी जाएगी, तो इस पर चार्ज हो जाएगा लैम्डा इंटू आर डी थीटा. लैम्डा की वैल्यू प्लेस कर देंगे लैम्डा नॉट साइन थीटा. तो इस एलिमेंट पर हमें चार्ज मिल गया और इस चार्ज को अब इंटीग्रेट कर दिया जाए क्योंकि चार्ज तो स्केलर है. वी कैन इंटीग्रेट इट इन द लिमिट 0 to pi. So answer will come out to be 2 lambda naught r. Now let us try to find dipole moment. So for dipole we need equal and opposite charges separated by some distance. We multiply distance between them by one half charges, their magnitude. अगर separation d है तो इस arrangement का dipole moment क्या लिखा जाता है? q into d, directed from minus to plus. So due to symmetry, I have taken advantage of symmetry. We know that sine of theta is same as sine of minus theta. To add this negative angle minus theta, we can imagine charge of angular width d theta here, d theta here. If here in d theta charge is dq, then here in d theta charge will be minus dq. And we can this separation as angle of using simple trigonometry. So we can write the dipole moment of this pair of charges as dq into d, that I have done here. dq minus dq, and they are at angular position theta. So separation between the charges will be 2r sine theta. And I have explained why there will be minus dq if there is dq. So dipole moment of this pair will be dq into d. And dq, as we have written initially here, the same expression can be used here, lambda r d theta sine theta, and d is 2r sine theta. So this will be the dipole moment of two small charges dq and minus dq separated by d, and direction will be minus to plus. Since all such pairs will have direction in same, all such pairs, we imagine pair here, all dipole moment will be in same direction. So we can directly integrate dipole moment of this dq and minus dq. So there we will get total dipole moment. This dp can be integrated, and limit should be carefully taken. Theta will be 0 to pi only, not 0 to 2 pi, because I have gone one side and taken the other side also. So by taking one theta, we have used both charges. We can vary theta only 0 to pi. By going from 0 to pi, we will cover the whole ring, right? So p will be equal to integral dp, and finally you can integrate it by 1 minus cos 2 theta by 2, and then use common relations. You can prove that this integral will come out to be pi by 2, and so dipole moment should come out to be lambda naught pi into r square. And the next part is calculation of field. This is slightly tougher, not very tough. And calculation of field by half ring is given in many books, so it is not a very unique problem, but let us do it just for practice. Again consider dq charge. Like earlier, which is spread an angle d theta, and that dq will be given by same expression as earlier, lambda naught sine theta r d theta. Now field is a vector, that is important here. dq will create field like this, and we take another dq, we will get field like this. So all field will be in different directions. So what we should do, we can take the component of this field along x and y and integrate these separate components. That I have done it here. I have taken component of this d in x direction, minus sign I have placed to indicate it is in left direction, and dy downward, this much. Value of d is simply written as dq upon 4 pi epsilon naught r square, because the distance is r. dq will be replaced by this expression here, and simplify करके ये आ जाएगा. We will get this expression of d, and then dx multiply here d by cos theta, that I have done it here, and then use integral, because all dx will be in same direction. जितने भी dx आएंगे सारे same direction में, तो we can integrate it. 0 to 2 pi we will get. I have done it here 0 to 2 pi because I have not used this angle along with this. This part is covered by this only. So we will get this as 0. If you integrate it, it will be sine 2 theta by 2, and sine 2 theta का integral simple 0 to pi में 0 आ जाएगा. And by symmetry also we can realize कि here there will be another element negative here. Its field will be like this, and these two will produce field in y direction. So we can expect that net field will be in y direction. So x component has to come negative. 0. That we have obtained 0. Even we can leave it by symmetry. We need not to calculate it. Thus, for the practice, I have done it here. Now, field in y direction will be equal to integration of this term, and this d sine theta all will come out as per this expression. Here we will get sine square theta integral by multiplied by some other parameters, and this integral will come out to be pi. Limit will be 0 to 2 pi because, as I have explained here, theta is varying from 0 to 2 pi to cover the whole ring. This minus sign indicates that field will be in this direction, negative y. So actual answer should be this much field in negative y direction. You can cross check if my calculation is all right. This should be the correct answer. Right? तो इसमें केवल इतना ही केयर करना है. We have to calculate. We can do other way also. We can take this element and combine field of these two by symmetry. Then their resultant will be in this direction. So we can integrate this net field and vary theta from 0 to pi. Avoid integration for x, which is due to symmetry, it has to come to 0. So anyway, we will get the same expression.